Hello students, welcome to Akshar Academy YouTube channel. In this session, I am going to discuss work, power, energy. In this, applications of work. Let us discuss. The work done by force in various situations. Now I will discuss applications. If you like this video, please subscribe to our channel. Please share your valuable comments in the comment section. Okay, let us go to the today's session. A body of mass m is lifted from ground to a height h by using a minimum force F. See here, this is the body which is placed on the earth, and this body is placed and it consists of mass m, and a body of mass m is lifted from the ground to a height h. This is the height by using a minimum force. So we are lifting this body up to a height h from the ground by using a minimum force F. So the minimum work done by the lifting force is W is equals to F into S, F dot S. So W is equals to, that is equals to F is equals to mg, mg into S h. So W is equal to mgh. Work done by the gravitational force is minus mgh. Now we will discuss second application. A body of mass m and density d1 lies in a non-viscous liquid of density d2. See here, now we are placing the body of mass m and density d1 lies in a non-viscous liquid of density d2. So the minimum work done to lift the body with a uniform velocity through a height h in the liquid, that is W is equals to minus mgh of 1 minus d2 by d1, that is equals to minus mgh of 1 minus 1 by rd, relative density. Next one, a bucket full of water of total mass m is lifted up with uniform velocity using a uniform rope of mass m and length L. See here, a bucket full of water of total mass m is lifted up with a uniform velocity with a uniform rope of mass m and length L. So work done by the lifting force in lifting the bucket full of water by means of the rope is W is equal to mgl plus mgl by 2. Now fourth one, a pendulum of length L carries a bob of mass m. The bob is pulled aside through an angle theta with the vertical by a horizontal force F. This is the pendulum of length L carries a bob of mass m. The bob is pulled aside through an angle. So this is the ball. Now this bob is pulled aside through an angle theta with the vertical by a horizontal force F. Work done by the gravitational force, that is Wg is equal to minus mgl of 1 minus cos theta. Work done by the horizontal force F is W is equals to Fl sin theta. Now fifth one, a uniform chain of mass m and length L is suspended vertically. The lower end of the chain is lifted up to the point of suspension. Work done by the gravitational force is W is equals to minus mgh. This is a uniform chain of mass m and length L is suspended vertically. The lower end of the chain is lifted up to the point of suspension. The work done by the gravitational force is minus mgh, where h is the height gained by center of gravity of the lower half of the chain with respect to its initial position A. So H is equals to L by 2 minus L by 4 after taking LCM L by 4. Work done by the gravitational force is W is equals to minus mg L by 4. So therefore W is equals to minus mg L by 4. Now next one. A uniform chain of mass m and length L rests on a table, having 1 by nth part of its length hanging down from the edge of table. So the work done by the pulling force to bring the hanging part of the chain on the table is W is equals to m by n into GH. See, this is a uniform chain of mass m and a length L rests on a table, having 1 by nth part of its length hanging down from the edge. So work done by pulling force to bring the hanging part of the chain on the table is W is equals to m by n in mgh or m by n into gh or mgh by n, where h is the height gained by center of gravity of hanging chain with respect to the edge of table. So W is equals to m by n into g into L by 2n. Therefore, W is equals to mg L by 2n square. A uniform chain of mass m and length L rests on a smooth horizontal table with 1 by n1th part of its length is hanging from the edge of the table. Work done in pulling the chain partially such that 1 by n2th part is hanging from the edge of the table is given by W is equals to mgl by 2 of 1 by n1 square minus 1 by n2 square. Now, I will discuss MCQs. First one. Find the work done in lifting a stone of mass 10 kg and specific gravity 3 from the bed of a lake to a height 6 meters in water. 98 joules, 392 joules, 196 joules, 294 joules. So, W is equals to, that is work done is equals to mgh of 1 minus 1 by Rd, that is 392 joules. Now next, uniform chain of length L and mass m is lying on a smooth table and 1/3 of its length is hanging vertically down over the edge of the table. If g is acceleration due to gravity, the work required to pull the hanging part of the table is mgl, mgl by 3, mgl by 9, mgl by 18. So the work required to pull the hanging part of the table is mgl by 18. Now discuss work done by constant and variable force. Work done by the constant force. If a constant force F displaces a body by S bar, then work done by the force W is equals to F bar dot S bar. So work done can be calculated from the force displacement graph. See here, this is a force displacement graph. By using this graph, we can calculate work done. The area enclosed by the graph on the displacement axis gives the amount of work done by the force. So, force displacement graph of a constant force is a straight line PQ. So, work is equals to area OPQR. So, that is OP into OR. So, W is equals to F into S. Work done by a variable force. A varying force F in x direction displaces the body from xi to xf. So to find work done by this force, the distance between initial position xi and final position xr is divided into small segments of length delta x. So as delta x is small, the force F is considered approximately constant in that segment, and work done in moving through each of the segment is delta W is equals to Fx into delta x. So therefore total work done by variable force is sum of all the works. Delta W equals to W, that is equals sigma xi to xf Fx into delta x. So the displacement delta x is allowed to approach 0. The sum approaches a definite value which is total work. Hence, W is equals to limit delta x tends to 0 sigma xi to xf f of x into delta x. Hence, W is equals to integration of xi to xf fx dx, where limit stands for the limit of the sum when delta x tends to 0. So, a plot of varying force in x direction is shown in figure below. See this figure, plot of varying force in x direction. This is the work, and here area delta A, that is equals to f of x into delta x. So, the area under the graph between xi and xf gives the initial and final, gives the value of total work done. Now, discuss MCQs. The area between force, displacement curve and displacement axis gives power, time, impulse, work. The area between force and displacement curve and displacement axis gives work. A position dependent force F bar is equals to 7 minus 2x plus 3x square newtons acts on a small object of mass 2 kg to displace it from x is equal to 0 to x is equal to 5. The work done in joule is 70 joules, 270 joules, 35 joules and 135 joules. So that is work done in joule is 135 joules. Now discuss numericals. A force F, that is 6I minus 8J Newton, acts on a particle and displaces it over 4 meters along the x-axis and then displaces it over 6 meters along the y-axis. The total work done during the two displacement is 72 joules, 24 joules, minus 24 joules, 0. So the answer is work done during the total two displacement is minus 24 joules. Let us discuss the solution. The force F bar is equals to 6I minus 8J newtons and displacement S bar is equals to 4I plus 6J meters, and work done W is equals to F bar dot S bar, that is equals to 6I minus 8J dot 4I plus 6J. So 6 4 is 24, I dot I 1 and 8 6 48, 8 6 are 48, J bar dot J bar 1, 24 minus 48. So the answer is minus 24 joules. So the work done, total work done during two displacement is minus 24 joules. Next, the amount of work done in pumping water out of a cubical vessel of the height 1 meters is nearly 5000 joules, 10,000 joules, 5 joules and 10 joules. Now let us discuss with solution. H height they given as 1 meters, G 10 meter per second square, W is equal to mgh. Substituting values, here m is equals to v into rho, that is rho is nothing but density, mass per unit volume is known as density. So from that mass is equals to v into rho. So W is equals to v rho gh by 2. Now substituting W is equals to 1 cube into 10 cube into 10 into 1. Here the given H equals to 1 and G value 10 and this water volume here 1 and its density 10 cube by 2. So 10 cube into 10 by 2. So that is 2 ones, 2 ones, 2 5s, 5 into 10 cube. So nothing but 5 into 1000. So 5 into 1000 work done, W is equals to, we are getting 5000 joules. Okay. So work done is equal. Next one, a force of 3 x newtons acting on a body of mass 10 kg along the x-axis. Displaces it from x equals to 2 to x equal to 6 meters. The work done by the force is 20 joules, 48 joules, 68 joules, 86 joules. Now let us discuss with solution. Force F they given as 3x newtons, mass m 10 kg. Displacement x equal to 2 to x equal to 6 meters. So work done W is equals to integration of x equal to 2 to 6 F dot ds. Substituting F here 3x. So x equals to 2 to 6 3x into dx. Integration of x square by 2. 3 into x square by 2 limits x equal to x equal to 6. So that is equals to 3 into 16. Here applying the limits 6 square by 2 minus 2 square by 2. We are getting 16. Here W is equals to applying the limits x equal to 6 nothing but 6 square by 2 upper limit minus lower limit 2 square by 2. So W is equals to 3 into 6 square nothing but 6 6 36 minus 2 4 is 2 square 2 2 is 4 taking LCM 2. So work done W is equals to 3 into 36 minus 4 32 by 2 2 ones 2 16. So that is equals to 3 into 16. 16 3 is 48 joules. Okay. Work done with the force is 48 joules. Now fourth one. A lawn roller is pulled along a horizontal surface through a distance of 20 meters by a rope with a force of 200 newtons. If the rope makes an angle of 60 degrees with the vertical while pulling, the amount of work done by the pulling force is 2000 root 3 newtons, 1000 root 3 newtons, 2000 newtons, 1000 newtons. Now let us discuss solution. Distance S they given as 20 meters and force F they given as 200 newtons. Angle they given as 60 degrees. So W is equals to Fs cos theta. Substituting values 200 into 20 into cos 30. 200 into 20 4000 into cos 60 root 3 by 2. 2 ones 2 2000s. So work done by the pulling force is 2000 into root 3 newtons. Here cos 60 root 3 by 2. Okay. Thanks for watching this video.